All right, today we're in section 9.4, real numbers. You think, well, what's a real number? I mean, I didn't know that there was a fake number, and you're right, okay? So pretty much any number that exists in our numeric system is called a real number. But within real numbers, we have two categories of numbers. We have rational numbers, which we actually have already learned about. Those numbers terminate or repeat. Irrational numbers neither terminate nor repeat. You need to write that in your notes. Rational numbers either terminate, so they have an endpoint, or repeat, so they're repeating decimal. Irrational numbers are the opposite. They neither terminate nor repeat. All right, so in example 1, well, let's look at this chart first, okay? And this is what I was talking about. There's two categories. There's rational numbers and irrational numbers. So rational numbers are things like integers and whole numbers. Did you know that they're actually not the same thing? Now, all integers, no, let me take that back. If it's positive, okay, whole numbers only have to do with positive numbers. If they're negative, they're actually not whole numbers. They are still integers. Integers are positive and negative. We know how to work with integers, but whole numbers are only positive numbers. Whole numbers greater than 0. Okay, so if you think about that for a minute, it actually does make sense. Whole numbers have to be greater than 0. So like -2, while it does not have a decimal attached to it, is not considered a whole number. Just keep that kind of tucked in the back of your mind for maybe an SAT question, because it might ask you something like that. All right, so classifying real numbers. So here's some examples. There's a terminating decimal. So yes, it's rational. Well, there's a repeating decimal. So yes, it's rational. And then you have a decimal like this, 4.35889,894. All right, obviously that's non-repeating and non-terminating, so that would be irrational. Irrational. Okay. Classifying. So in example 1, let's go ahead and look through these values and determine whether or not they're rational or irrational. I must look at the decimal version of these values in order to determine that. All right, so let's go ahead and evaluate that. So what did you get for a decimal when you converted 2/3?
0.6 repeating.
Okay, you got 0.6 repeating. So since it's a repeating decimal, is it rational or irrational? Rational. All right. And then what about the square root of 100? What's the square root of 100? 10. So that's definitely rational, right?
Yes.
Okay, it's rational unless it doesn't terminate and doesn't repeat. What about square root of 6?
2.4494.
Yeah, so write down the first few decimals and then a ... after that to kind of show that it keeps going forever, and then you say it's irrational. What about the square root of 16 over 25?
0.8.
0.8. Okay, so that's basically what you need to know. Now we are going to do a couple other examples, but this one's definitely the most important part, how to tell whether or not a number is rational or irrational. Now in example 2, we're just taking it a step further, and we're actually looking at a set of numbers. Sorry, that's example 3. In example 2, we're comparing real numbers. Wrong slide again. Let's see if third time's a charm. All right, there we go. Comparing real numbers. So compare the square root of 2 to 9 over 5. Well, first we have to change both of these to decimals. Go ahead and do that. Okay, so square root of 2 compared to 9 over 5, we change them to decimals. And now we can clearly see that 1.8 or 9/5 is bigger, so I draw a less than sign in my answer and box it in. So the square root of 2 is less than 9 over 5, and I can see that because I converted them to decimals and compared them. All right, did you get that? Okay, so let's do one more of these. Comparing. All right, now the square root of 4 to 3 over 2. All right, so square root of 4, guys. 2. 3 over 2 is 1.5, so square root of 4 is bigger. And you have a whole section like that. That's all you do, okay? Now, in the last example, now we're taking a group of those, and we're going to put them in order, least to greatest. All right, so we're going to take all these values, and we need to write them all as decimals. Now, negative 2.8 is already a decimal, so just write the other 3. Go ahead and write them in order, too. Because on the number line, when you graph them, you're actually going to graph them back in their original format. So it's important you know which one matches with which. So in decimal version, 4 over 3 is 1.3 repeating, negative 2.8, 1.73 for square root of 3, and negative 2.24. So where should I start my number line? Should I start it at negative 10?
No.
Why not? I like the number negative 10, so why not start at negative 10?
That's so long.
Because given the range of values here in my number set, negative 10 is a total waste of space, right? Because what's my lowest value? Negative 2.8. So what do you think needs to be the first number on my number line? Negative 3, just past the lowest value. And then I just increase, and guys, on your homework, you don't need to go by halves, just go by whole numbers all the way up. Now I went up to 3. Technically I didn't have to go that far, I just had that number of dashes, so that would be fine. All right, now on your number line, here's what's important too, is that you label it according to the original value. So you use their decimal values to determine where it goes on the number line, but then label it with the original value. So the lowest value is negative 2.8. What's the next lowest value? Which is the negative square root of 5. Okay? And guys, if you can't like fit them next to each other, you can just kind of like draw it and write an arrow. Okay? But see how I labeled it negative square root of 5? Make sure you label it in the original format. Go ahead and label the other 2 points. Alright, so does yours look like that?
Yeah.
Okay, so you have, I think, 2 of those on your homework tonight. Alright, and that pretty much wraps it up for what you need to know for 9.4.
That's really short.
Yep.